For example 2, we want to find the values of the six trig functions of plane theta if all we know is that cosine of 2 theta is 4/5 and that theta is between 90 and 180. That's all we know. And now, remember, we want to find the trig functions of single theta. So how do I take something from cosine of 2 theta and bring it into a single theta? We have to use one of our double angle identities, right? Okay. So do I want to use the first one, the second one, or the third one? Well, why can't I use the first one? I can't start out with this one. I can't start with cosine squared minus sine squared
Because you don't have something.
equals, why did I do that? Equals cosine of 2 theta. Why can't I start with that? Because I don't have sine or cosine, right? So I want to start with one that only has 2 variables in it, not 3. Typically, I hardly ever use this one because it requires two things to be plugged in. So what I usually do is use one of the others.
Hey, that's the same thing as 1.
No, that would be if it were added.
Oh, yeah.
Not subtracted. Okay, so let's pick another one. Cosine of 2 theta equals, I don't know, you want to use 2 cosine squared minus 1? Yeah. 2 cosine squared minus 1. Which one do I know, the left one or the right one?
4/5 equals cosine
The
2
left one.
squared.
So 4/5, so I'm going to substitute there, equals 2 cosine squared theta minus 1. And then we just want to algebraically solve that for cosine. So we'll add 1. Adding 1 is the same as adding 5 over 5. Okay?
9.
So we have 9/5 is equal to 2 times cosine squared of single theta.
5 and 2.
If I divide by 2, does that give me 9/10? Or what does it give me?
4.5 over 2.5.
Did you know that one way to divide by 2, if you have a fraction and you're trying to divide it by 2, you just multiply the bottom by 2? Dividing by 2 is the same as multiplying the denominator by 2. So if I divide both sides by 2, I get 9/10 equals cosine squared.
And then square root.
And then cosine is equal to
3 over square root of 10.
plus or minus, which one? Defining quadrant 2. Which one?
Plus.
Quadrant 2 cosine is negative. So negative square root of 3 over, well, square root of 9 over 10, which is what, 3 over square root of 10? Okay. Here's where we are. And I haven't rationalized yet. But let's take a minute and let's just look at that. That's cosine. Okay? Now I have to find the other 5. So I'm going to come over here and I'm going to kind of make a list. I don't know sine yet, but I do know cosine. I know that cosine is negative 3 square root of 10 over 10. Do y'all agree with that?
Yes.
Okay. I don't know tangent yet. What do I write next? Do I usually do cotangent? Isn't that the order your book does them in? And then we do secant. And then we do cosecant. If I know cosine, I also know which one. All right. Do you see that it's easier to reciprocate not from here, but from here?
Yes.
That is why I didn't immediately rationalize it. Because if I'm going to use it to find something else, it's easier to find something else before you rationalize. So what is the reciprocal of negative 3 over the square root of 10?
Square root of 10 over
Negative square root of 10 over 3? Yeah? And we always just leave the negative on top. We don't flip it. Okay, so that's what I know so far. How can I use that to find sine?
We know the R.
I know the R, and I know the X, right?
Mm-hmm.
And what quadrant am I in? I'm in 2? Yes?
Wait, you're watching that?
Okay, okay, I'm supposed to be in 2, but actually I'm drawing in 3 is what you're telling me. I've needed a lot of do-overs today. Okay, quadrant 2, that's this one, right? Okay, this is my X, and this is my R. So my X is negative 3, my R is the square root of 10, and then we have to use the Pythagorean theorem to find my Y. So we'll say X squared plus Y squared equals R squared. So 9 plus Y squared equals 10. So Y squared is 1. So Y is plus or minus 1, and in this quadrant it is positive 1. So what I did was I drew with the triangle for theta. This is the triangle for single theta. Now I can use that triangle to find anything I want. So sine is y over r, which is 1 over the square root of 10. So that would be square root of 10 over 10. All right. That would make the cosecant, the reciprocal of that, that would be your r over your y. So yeah, so it would be square root of 10 over 1. And then we just need tangent. Tangent is y over x, which is negative 1/3. And cotangent is x over y. Okay, so let's make sure we understand exactly what we did there. I started a problem and I gave you one thing. What did I give you? I gave you the cosine of 2 theta. Okay, we used a double angle identity to solve for cosine of single theta. Then we drew a triangle for single theta, and we solved for the x, the y, and the r using what we knew about cosine. Once we did that, we were able to use the definitions to find the other 5. Make sense? Great. Okay, for this example, we're going to verify that cotangent of x times sine of 2x equals 1 plus cosine of 2x. So let's start on the left side and let's see what we got. Well, obviously, I want to get rid of that cotangent, right? So what's the way to get rid of cotangent?
Cosine x over sine.
Yeah, I can change it to cosines and sines. So we can use the quotient identity and say that cotangent is cosine of plane x over sine of plane x, as long as you keep the angle. Now, sine of 2x, I only have one option for. What is it?
X plus sine
Is it?
A cosine.
Let's see. So I could expand it to 2 sine of plane x, cosine of plane x, right? Okay. Oh, hey, this is nice. What happens?
What?
The sines cancel. So really, I have 2 cosine squared. So 2 cosine squared of x. Does that make sense? Yes?
Where did the cosine come from?
I expanded the sine of 2x using the double angle
You took
identity.
2 sine A,
2
cosine.
sine of plane x, cosine of plane x. Yeah. Okay. Is everybody okay that the left side equals 2 cosine squared? Now, some of you might be able to see the connection, but if you don't, just go work on the right side and think about this one. 1 plus cosine of 2x. Well, this guy right here,
Is cosine squared A
well,
minus?
actually, I get 3 options for that one. I can either replace it with
yeah.
cosine squared of x minus sine squared of x, or I can use 2 cosine squared of x minus 1, or I can use 1 minus 2 sine squared of x. I want to use the one that looks the most like what I'm trying to get it to equal. I'm trying to get it to equal 2 cosine squared.
2 cosine squared x minus
Right. So I'm going to replace that with 1, and keep the 1, plus change the cosine of 2x to 2 cosine squared x minus 1.
The ones
they
cancel.
And then the 1's cancel. And now we have both sides are equal to 2 cosine squared of x. So therefore, we say that identity is verified.
Big old